To begin, let's consider an electric field which contains 2 points A and B. Now we know that the electrostatic force is conservative, which means that the work done in moving from point A to B will not depend on the path taken. It simply depends on the position of the 2 points, which means that if I take this longer path, which performs a right angle turn and then reaches point B, the work done in going along that path will be the same as traveling along the straight line. So what this means is that W1 is equal to W2, where this is W1 and this is W2. Now what we know is that the voltage of a system, or the potential difference, is the work done in moving a point charge, right? So we can replace the W's with VQ. So V1Q would be equal to V2Q. I know the Q's cancel out, so that gives us V1 is equal to V2. Now what this means is that within an electric field, the potential difference between 2 points is constant regardless of the path that a charge takes. We're going to use this concept in finding the resistance of a system in parallel. Okay, now let's create a system of resistors in parallel as such. And R3. The first resistor is going to be R1, followed by R2 and R3. So now we learned that the potential difference between 2 points will always be the same regardless of the path that is taken by them. What that means is that the potential difference through R1 is going to be equal to the potential difference through the Y with R2 and that with R3. So V1 is going to be equal to V2, which is going to be equal to V3. Here I'm considering 3 resistors. You could use as many as you like, 1 or as many as you want. So Ohm's law tells us that V is equal to IR, right? So now we have a relation between all 3 potential differences. Now let's establish a relationship between all 3 currents. Let's suppose that the charge flowing through R1 is Q1, the charge flowing through R2 is Q2, and the charge flowing through R3 is Q3. And the total charge that has flown through the system, let's call that Q. So now Q1 plus Q2 plus Q3 is equal to Q, which is the total charge. Now if we divide all the terms by T, that tells us that the sum of all 3 currents, which is I1 plus I2 plus I3, is equal to 0. Now using Ohm's law, what we can do is we can replace I with V by R. So V equals IR means that I is equal to V by R. So the value of I1 is going to be V1 by R1. But since V1 is equal to V2, which is equal to V3, let's just call this V. So I'll erase the 1 over here. We don't need that. So now we have V by R1, which is I1. So V by R1 plus V by R2 is equal to, no, sorry, plus V by R3. This over here should not have been 0. I made a very big mistake, I'm sorry. This should be I. So here V by R1 plus V by R2 plus V by R3 is going to be equal to V by R. Here R is the combined resistance of all three resistors. R is what we are trying to calculate. So now if we divide all of these terms by V, if we basically eliminate the V's, that gives us some space. So this equation tells us that the reciprocal of the first resistance plus the reciprocal of the second resistance plus that of the third is equal to the resistance of the entire circuit. So this is how we come up with the relation of multiple resistances connected in parallel. Thank you.